ELI 5. If normal computers have zeros and ones, what do quantum computers have? If quantum computers can have multiple states at the same time, what are those states? These other answers are, I think, misleading. The most accurate way to explain it is that qubits are not numbers, they do not have discrete values. What they are is actually lines, or vectors. Imagine like you might have seen in algebra class where you plot a line from the origin going up in the y direction or sideways in the x direction, or some combination like diagonal up and to the right, etc. Except qubits are in 4 different dimensions. There are 4 perpendicular axes that define where they point. And they can point in any combination of these directions. Now there are 2 special directions we name 0 and 1. Under normal operations, you can rotate the qubit however you like in all 4 of the directions. That is what computing is on a quantum computer, moving around these qubits to point different ways. But at the end of the computation, you do a special operation called measurement. When this happens, the qubit snaps to either the 0 or 1 direction. Which one it goes to depends on how closely it was pointing to 0 or 1. The closer to 0, the more likely it measures to 0. But as long as it is not exactly pointing at one of those directions, there is some randomness in where it will end up. This is where the quantum randomness comes into play that people talk about. Part of the power of a quantum computer comes from the fact that these lines can point in an infinite number of directions, because angles are measured in real numbers, so you can rotate the qubits by arbitrarily small amounts. This gives you a lot of power for computation. Despite this, though, you can only actually store 1 bit of retrievable information in each qubit, because when you read it you always get out a 0 or a 1. So some very neat stuff happens during the computation, but at the end it still just outputs a normal bit string.